I would like to welcome three special guests from Intuit who will help us close out today's event. Here to talk about Intuit's Pulsar journey, please welcome Group Engineer Manager at Intuit, Surua Mohan, Staff Software Engineer Sankararao Rutu, and Platform Architect Sajith Sebastian.
Hello everyone, good afternoon. I'm Sajid Sebastian from Intuit. I'm an architect for the Intuit messaging platform. I've been with Intuit for last 9 years, and in the industry, I'm working as a software professional for last 20 years. My interested areas in distributed computing and platforms. With that, Shankara, can you please introduce?
Hey, good afternoon, everyone. I'm Shankar. I'm working for Intuit from past 9 years. I'm a staff engineer. I have a vast experience on designing and developing the software systems with deep expertise on Apache Pulsar and ActiveMQ. Surya, can you go ahead?
Thank you, Shankara. Good afternoon. I'm Surya Mohan, working as a group engineering manager at Intuit. Our team is responsible for building a platform as a service product using the Apache Pulsar, which we are offering to our internal client teams. I have close to 20 years experience. I'm very passionate about building horizontally scalable distributed systems. We are very excited to share our journey at Intuit, how we started with the Pulsar and what are all the learnings in this journey and what kind of incremental improvements we have done to the platform and how we are supporting to the customers. With this intro, I will hand over to the Sajid, who will take you back to our journey that is almost started 10 years back at 2015.
Thank you, Surya. So it's all started in 2010. One of Intuit applications started using ActiveMQ as a messaging platform for their asynchronous communication and queuing needs, right? And that team started, this was hosted in Intuit data centers, Apache ActiveMQ has been supported by Red Hat, and it is called AMQ6. We built on with a network of brokers architecture, and this platform started expanding its as a it evolved as a platform as a service. Eventually, at Intuit, it started. We have self-service enablements and everything enabled for ActiveMQ for our Intuit internal applications, and it evolved as a de facto messaging platform for Intuit. It became a service application service for Intuit from 2015. It is well established from that time on. So the messaging, since it became the messaging de facto messaging platform for Intuit, it is powering our major products like TurboTax, QuickBooks, Mint, many others, right? Everyone uses this platform for its asynchronous communication needs. So then, in 2016, Intuit started its journey towards cloud migrations, right? Intuit adopted AWS as our cloud service provider, and all of our services started migrating to AWS, and they started, parallelly they have started their monolith decomposition and microservices journey as well. So this platform became more relevant when the microservices journey for Intuit when it started, right? So by 2018, 2019, the AWS migrations of Intuit has been almost entered, but the microservices, the monolith decomposition became, the prime priority, and it's going at scale. So at that point, our system, this messaging platform, becomes, it is, even though it performs very good, very reliable, but it is a cost center because of static infrastructure, and it is not scalable. And the cloud native features of unavailability, it became a problem for us. And this started the quest started for finding a new solution, a cloud-native solution which can support Intuit asynchronous communication payloads, right? So the basic principles in front of us is, we need to have availability, 6 nines availability, 99.9999 availability, and very low latency. If somebody is writing from a region, it needs to write in the local region, and so that keep the cost high, cost very low, and it needs to, the recovery should be very faster, and cross-region things need to, for example, if some TurboTax in one region has some issue, they can fail over to the other region and continue the service without any problem. Like that, our platform has a problem, it needs to fail over very fast, right? So with that, our quest started, and we started evaluating multiple products like Apache Kafka, RabbitMQ, AMQ7, which is called Apache Artemis, RabbitMQ, etc. Finally, the winner was Apache Pulsar, right? So 2019 timeframe, we finished our process of identifying the right solution towards our message asynchronous communication platform, right? And that we have done by 2019, but that's not all. We have a huge problems to solve there, right? So all our customers are using JMS APIs. This is the scenario in 2020, right? So customers will not change. They don't want, this is just a messaging platform switch. They wanted to continue with JMS. That's the first problem. Then we also don't want the message duplication and the cost incurring due to cross-region message replication with the region-wise replication Pulsar offers, right? It is Intuit products are very high TPS products, and we don't want to do that. These messages to be replicated and become a cost center. And replication also causes duplicate messages in case of region failure, etc. So we started filling these gaps. The first thing we have done is, we have the initial thing we have done is JMS APIs for Pulsar. So we developed JMS APIs, and so that customers can migrate their code with just replacing the dependency. And then we have built a new architecture flavor of Pulsar deployment, which is cross-region. You can see here, this is a single Pulsar cluster spanning across US West 2, US East 2, and US East 1, but primarily US West 2 and US East 2. You can see that the Zookeeper cluster is spanning across 3 regions. This is to accommodate any region failover. So let's say US West 2 went down completely, still the Zookeeper quorum will be maintained with the help of the other Zookeeper and the US East 1, vice versa, right? But we make sure the Zookeeper leader is in the primary region of US West 2 or US East 2 by assigning right Zookeeper identifier, etc. So the next problem we have is, right to in the low latency writing. The low latency writing, we wanted to solve it, but Pulsar in a single cluster, the topic can be owned by broker in any region, right? This is a single cluster. The broker, the owner topic can be anywhere, which is not right. The first thing we introduced is namespace isolation. The West brokers will only have West prefixed topics, and East brokers only will have East prefixed topics. Here, one of the important component we have developed is custom discovery service, which was shipped with Pulsar 2.7 or 2.6, and we adopted that. We customized it for our needs, but right now it is not shipping with the Pulsar component, but we are configuring this service, custom service discovery from Pulsar proxy, and we have customizations in the Pulsar proxy as well. we have created a Pulsar client wrapper which initiates a custom lookup to during the registration of Pulsar consumer or a producer, which will go and take a look at that service discovery will convert that, hey, look at this topic and what is the actual from where this connection is coming, and give me which topic it needs to be connected. This custom discovery will return the new topic names, and so that the client actually initiates the lookup back again and latches to that particular topic. So this is a customization we have made. This is to solve the latency part of writing, right? And like I said in the previous screen, Route 53 endpoint, all our customers connect to, clients connect to Route 53 endpoints, and it is latency-based routing. The connection request will land on Route 53. If it is connecting from West, it will land on West proxy, and West namespace topic will be returned for producer. And if it is consumer addition, then it will return multiple topics, and we use multi-topic consumers wrapped in add consumer of a client. So that this is all underneath our clients' applications need not code all these things. Our wrapper for Pulsar client takes care of all this. With this, we have achieved high availability. Any region outage also will not cause a problem. It will simply, upon a connection timeout, it will simply fail over to the other region and things works fine, right? So with this setup, let me explain the current failover or current active-active setup, how it works in terms of a topic, global topics and its naming conversion with discovery, right? When a producer attempts to connect to a particular topic, first thing, it initiates a discovery, and the lookup call and the connect call lands on the Route 53 and latches to West region, since it is from West. And the first thing, the custom lookup call resolves that add producer call to a West topic, right? It is resolved to this, and then every other interactions with Pulsar is happening seamlessly without any problem, right? The lookup and adding the producer, everything is as usual. Only that custom topic conversion lookup happens here. And then, in case of a consumer gets added, the consumer connection lands on Route 53, and it will land on the local proxy. Let's say it lands on West proxy. It hits the discovery. It will translate, since it knows that it's a consumer add call, it will simply return multiple topics, West and East topic. The consumer, finally the Pulsar client forms a multi-topic consumer for this particular thing, right? So consumers always connected to 2 topics with the multi-topic subscription, and the producers always to connect to the local topic, right? With this, I will stop here, and I'll invite Shankara to explain the problems with this active-active setup and the resolutions.
Thank you, Sajid, for explaining the architecture and how the region failover works and how the active-active setup was done at Intuit. Now, let me walk you through the failover process and what are the limitations we had as of 2023. So let's say like the producer and consumer applications are in US West 2, and as Sajid mentioned, the consumer application will always connect to West region and East region, and the producer application will always connect to only one of the regions. Here, because the producer is in US West 2, it connects to US West 2 brokers. Now, let's see how the failover works. Let's say the US West 2 goes down. then the consumer will disconnect from the US West 2, but it continues to receive the message from the East 2. And with that, there is no problem with the consumer. But the producer is connected to only West 2, so now it will be disconnected because the West 2 went down. Now it has to connect to the East 2, so it is connected. But it takes a minimum of 120 seconds to 150 seconds to connect to the East region because it has to go through the Route 53, which will take around 120 seconds to realize that US West 2 went down, because it has to do some health checks, continuous health checks. Then only it will be able to realize it is West is down, and then it will connect to the East. So, and because it is taking 120 to 150 seconds, the producer will see an impact during this time. So this is the limitation 1. And the limitation 2 is, let's say I have brought the West 2 back. Right now, the consumer will connect automatically because it has a polling mechanism. The client SDK has a polling mechanism by default. It will be able to connect. But the producer still stays in the East region, and then it will continue to experience high latencies. So this is not a good thing, right? So the producer service had to restart in order to connect back to the West region. Imagine if it is a platform serving hundreds or thousands of services, asking all the producer service to restart in case of a region failover is not an ideal situation. So we need to find a solution for this. So these are the two limitations we had as of 2023. So in 2024, we addressed these two limitations. Again, let's take the producer application in West 2, and it is connected to West 2 brokers here. And now let's imagine West 2 before even that, like in the client SDK, we have implemented a component called the connection failure detector. So whenever there is a connection failure, it will immediately identify that, and then what it will do is, so here the West went down, it will detect that a connection failure, and immediately it will establish a connection to the East region. If you see here, the connection didn't go through the Route 53 URL. It is directly established a connection to the East. So that's why it is quicker here. The producer need not to wait for 150 seconds. It will immediately connect within less than 60 seconds. So with this, producer experience will be good. So this is how the limitation 1 was solved. And coming to the limitation 2, where if the West 2 comes back, the connection should come from East to West automatically. So the automatic fallback was not there, right? So for that, we have implemented another component called region availability monitor. It will continuously poll for the availability of the primary region. So as soon as the primary region comes back, like here the West is coming back, as soon as it is coming back, the availability monitor will detect it, and it will immediately establish a connection, and the East connection will be disconnected. So with this, the second limitation is also resolved. So these two SDKs on the these two components in the client SDK helped to resolve the limitations. With that, let me hand over it to Surya to walk us through the future of the Intuit Pulsar.
Thank you, Shankara, and thanks for illustrating our journey towards platform resiliency improvements and how we are raising the bar for customers. I'm really excited to share what are our next focus areas in this journey. I can broadly divide these focus areas into 3. The first focus area is, at Intuit, we really want to standardize the async API experience. We want to provide a platform agnostic experience in discovering the async APIs, and how developers can onboard, integrate. End of the day, we want developers to make use of async APIs seamlessly in a simplest possible way. That is where we are investing in some of the key areas of the standardization, leveraging some of the open specifications like async API specification in the CNCF Foundation, cloud events specification. Again, that is also one of the initiative from the CNCF. That is one of the main focus area for us. The second focus area is the platform resiliency. Today, we are supporting many tier 1, tier 2 services, and you all know how important the availability and platform resilience and robustness. So we continue to invest and further improve all these key vitals, such as availability, fault tolerance, and we try to make things better. And at the end of the day, we want to have our tier 1, tier 2 services comply to the robust disaster recovery best practices by lowering down the RTO and RPO. And the third biggest area is we keep on experimenting various use cases with Intuit client teams, so that how can we expand the scope of the Apache Pulsar by venturing into the new area supporting the new use cases. And this experimentation is a continuous process, and this is also where we want to make sure leveraging the best of the abilities of Apache Pulsar and give them to our customers to move with a greater velocity and efficiency. The last and final focus area, at Intuit, we take pride in giving back to the community. And in fact, in one of the core values of Intuit is always give back to the community. So we want to really contribute to open source community back, and especially strengthen the Apache Pulsar ecosystem. Recently, our team contributed to the CNCF cloud event specification by providing a validation framework. We really look forward to contribute for more such kind of opportunities and strengthen this community. And in that process, we really want to learn as well as raise the bar in delighting our customers.
Thank you, everyone, for listening to us. This is our journey, and we are open to questions. Please ask any questions, and we will try to answer as much as we can. Thank you.